Trasmetti dal vivo. Okay, we're live now.
Bernard disappeared. Hello, I warmly welcome you to our 38th webinar by the Academy of Space Renaissance International. My name is Sabine Heinz and I'm the person responsible for our webinar series. And on the 3rd of April 2023, I'm really delighted that you have come to join us. Our today's special guest is Adriano Ottino. And hello, Adriano.
Hello.
He is our vice president, and he's also one of the founders of SRI. And I also would like to welcome, Adriano will talk today about the booming new space economy. And I also would like to welcome Bernard Foying. Is he here?
Yes, I am here. So I reconnected because we went in our observatory, which is outside, as you can imagine. And I came back to a warm studio where I can follow. You hear me? Yes?
Yes, we can hear you, but
exactly.
We can't see you anymore.
I wanted to introduce you to some of our new students from Eurospace Cyber Academy, but also they are going to be active in Space Renaissance. So we have 2 students coming from Dublin, they are physicists, and then we have 1 student in international relations and policy that is also attending this seminar.
But we're not seeing you.
We cannot see you. Your camera is switched off.
Oh, yeah. And so I, yes, so, and so, yes, we have, okay, so Ava is joining us. She just came from Venus now. We were observing the Venus with some of the other astronomers. And so we have started actually now the first day where we could meet again all in Leiden, where we had a series of discussion on our experimental project. But we have also some preparation of very important event that we are going to organize in Ibiza, a Eurospace Hub forum, where we invite many of you to participate. And so that's what we are doing this week. So a mixture of research, of some coordination, and also experimental activities. We had the beautiful days, beautiful sky. So we observed the sun, we observed the moon, Venus, Jupiter, all possible destinations for Space Renaissance, of course. So now I would like to introduce Eva. So, yes, okay. Mm-hmm.
Perfect.
Yes.
So the audio.
Yeah.
But we still cannot see you, so.
Yes, now we can. There is a second connection.
Okay.
Hello, can everyone hear me?
Yes. Hello, welcome, Eva.
Hello, everyone. It's wonderful to be here.
Broken again.
So we have always 2 systems. We need always a backup. So Eva is going to continue. You saw her shortly, but now you can hear her.
Yes, sorry, we're having some technical difficulties, but it's wonderful to be here. Thank you so much. My background is I am a student at Sciences Po Paris in France. I study political science, international relations, and now with Bernard, I am focusing on international outer space law. It's wonderful to see some familiar faces here that I had the pleasure to meet just this past week at the IAF spring meetings. Wonderful to see you. Thank you so much for having me.
Thank you, Eva.
Welcome.
I am impressed by your study, and definitely we need you at Space Renaissance. So please join as a member as soon as possible. Okay.
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 Great.
Yeah, I can go on, or do you have more students to introduce?
Yes, the others are really busy navigating on the surface of the moon through their telescope. But
So
I want just really to say that we are we are following this in parallel to being in orbit around the moon with our telescope, and because clearly we are very interested in science, in technology, exploration, but it's very important also to look at what will be the opportunities for economy, for development, for humanities, and of course for a space renaissance beyond the Earth. So we are looking forward for this talk. Thanks, Adriano, and thanks also, Sabina.
Thank you,
Bernard.
And your students.
I also would like to welcome our audience. We have people, mostly members and speakers from our webinars. We have people watching from Norway. Hello, Ina. We have someone watching from Cupertino, California. Jim Crisafulli from Hawaii. Aloha. Samuel Coniglio from Northern California. Ghanim from Kuwait, Werner from Austria, Werner Grandel, you also was talking already for us, and Denis Rivero from Portugal. Welcome, and we are really happy that you are joining us. And I would like to introduce our today's speaker, Adriano Ottino. He's born in Moncrivello, is correct, yeah? Vice President of the SRI, and he is co-founder and former president of the Space Renaissance Initiative since 2010, Space Renaissance International. And Adriano is diplomed in industrial electronics, acting since 1978 as a software and system engineer, then project manager and entrepreneur in the field of real-time automation systems. His insatiable curiosity and the desire to engage in frontier fields have led him to work in the aerospace environment and to devise and develop an integrated software system supporting the systems engineering and project lifecycle management processes. Adriano authored and co-authored several books, papers, and articles on the theme of civilization expansion into the outer space. Adriano, we are really looking forward to listen to your lecture. The stage is yours, or the floor is yours, and you may share your screen.
Thank you very much. Now I will try to share the screen. Yes, this one. Good. And okay, can you see it?
Yes.
Okay, so the new space economy, history, reality, and perspectives. So we will have a look at the history and what is today and what it will be likely, hopefully, to be tomorrow. So before there was a traditional aerospace, and we will see the differences between the new space and the traditional aerospace, characteristics and differences. The current scenario, topics of major interest and opportunities. So, starting with history, what there was before. Traditional aerospace, a space agency, captive market, dominated by lobbies like aerospace, defense, and research. The so-called astronautical club was only made by 3 countries, USA, Russia, and lately China. The cost of the Earth to orbit transport was more than $40,000 per kilogram. And the access to space was provided during the last 20 years, more or less, by space shuttle that costed $200 billion to develop. So far, The major space agencies of the world invested $2 trillion of public money in space. Born with the launch of the Sputnik satellite on October 4th, 1957, space exploration has been developing for over 60 years. The main space agencies have spent about $1.7 trillion through their history. We can estimate an approximate total of $2,000 billion invested globally by the governments of planet Earth in space. Yet such investment is ridiculous when compared to the global military spending that is $2 trillion per year, not in 60 years, but per year. An enormous figure when compared to other public expenditures such as education, public health, and public transport system. As the space investment paid off for the taxpayers, the effects on daily life are of primary importance. All aspects of daily life are influenced by space technologies. However, only in the last few years, we are seeing the opening of the high frontier to civil development. So what is the main requirement of exploration of space? It is the so-called Planet B. Is the goal of a space program only to improve our life on the surface of our mother planet? The needs of the main stakeholder of space exploration, that is the world civilization, include many other goals that improving our life on the surface of the mother planet. One of the main requirements is to contribute to a sustainable survival and further progress of civilization. 8 billion Earthlings can no longer survive and continue to develop on just one planet. Space exploration must therefore help civilization to expand beyond the limits of Earth's atmosphere. As the dramatic multiple crises demonstrate, pandemics, climate change, environmental degradation, scarcity of resources and consequent conflicts, mass migrations, we certainly need one or more planets B. We are dramatically learning the hard way that the only sustainable development is outside our planet. That is, we shall start expanding into the solar system as soon as possible. This guy is a pilot, is William Knight, and he was the pilot of the X-15. This was a suborbital airplane, a military suborbital airplane, quite different with respect to SpaceShipOne, the Virgin Galactic suborbital plane for tourists. This was a military thing, therefore just a rocket with a cockpit that can be piloted only by very, very trained pilots. So we have a serious delay. Space agencies are late in delivering Planet B, only partly due to the technological limitation. From 1959 to 1968, NASA developed and tested X-15, the first fully reusable two-stage spacecraft, two-stage to-orbit spacecraft. X-15 made almost 200 flights, including 18 at suborbital altitudes, the same concept of scale Composites, SpaceShipOne, and Virgin Galactic SpaceShipOne. A few years later, the first space shuttle project by Kraft Erike was based on the same concept, but the developed system was only partially reusable, as we know. Had the X-15 strategy continued, we would have had reusable launch vehicles at least 40 years ago. The civilization may be on its way to expanding into the solar system. We could have industries in Earth orbit, cislunar economy, use of lunar and asteroid materials, fuel production in space. Technology wasn't a hindrance, as demonstrated by Branson and Musk. Short-sighted policies and lobbies have been a huge and heavy burden on human progress. The cost of Earth-to-orbit transport has been kept artificially very high for more than 40 years to accommodate the lobbies of expendable rocket manufacturers. So this was the configuration of the original space shuttle program. It was due to be brought at 30 kilometers altitude by a big carrier airplane, and then go to space from that by its own rockets engines. Kraft Erike intended the space shuttle as an umbilical cord to space. Inexpensive transportation would ensure capacity to carry pilots into Earth orbit, a gateway to cislunar and interplanetary destination. Erike also proposed a version capable of reaching higher Earth orbits. Erike in the 70s campaigned vigorously for a strong space program, including a fully reusable space shuttle, evolution of the X-15 concept, an orbital space station as a spaceport for every place in space, industrialization of the geolunar region, and Mars exploration. The program was to develop in the 70s and 80s for the benefit of the United States and all humanity, with full awareness that civil space development will be the only sustainable growth. Unfortunately, Erike lost his battle. Space shuttle was not 100% reusable. The space station had to wait. The moon is still uninhabited today. Mars was rejected as a target distant. The expendable rocket lobbies had won that battle. But we had, in the early 2000 years, the birth of new space. In 2004, Scale Composites won the XPRIZE. In 2015, SpaceX from startup from the time of the reusable rockets. In 2021, Virgin Galactic and Blue Origin start to suborbital tourism. In 2023, SpaceX experienced the first 100% reusable orbital vehicle. Crossing our fingers, the first orbital flight of the Starship prototype will fly in few days, maybe. Okay, we don't want to to make an announcement that then will be denied. Okay. However, the space economy global turnover from 2009 to 2021 kept on growing at a very, very high pace, reaching end of 2021 a figure near to 500 billions, so half a trillion dollars. So the XPRIZE was the first key milestone of that process. Gregg Maryniak and Peter Diamandis put a prize of $10 million to be given to the first company, private company, without any government help, that was able to reach 100 kilometers altitude and to repeat the same flight in few days, at 1 week distance, with only a refueling and a normal maintenance of the vehicle. That thing was made by Scale Composite, the company owned by Burt Rutan. They call him one of the legends of aviation. And the purpose of the XPRIZE was to reduce the risk and cost of going into space, incentivizing the creation of a reliable, reusable, privately funded and managed spacecraft, so as to finally make private space travel commercially viable. Before the Ansari XPRIZE, spaceflight was the sole province of governments. Space tourism was considered too dangerous and expensive for the general public. Space exploration was neither possible nor affordable for the private sector. About 20 companies participated to the XPRIZE from all over the world. The XPRIZE requirement, I already said it, was to reach 100 kilometers and repeat the trip within 2 weeks. So in 993, 903, and in 2004, 2 key milestones a century apart. On December 17, 1903 in North Carolina, the Wright brothers, Wilbur and Orville, took off for a few seconds and a few meters with an aircraft propelled by a rudimentary propeller driven by a rudimentary engine. On September 27, 2004, in the Mojave Desert, Mike Melvill reached an altitude of 100 kilometers aboard the SpaceShipOne, a suborbital vehicle built and privately financed. Okay, I already said all of this, so I will not insist on that because we have many slides, so we try not to be steady. So this is Burt Rutan on the top of SpaceShipOne. And this is the evolution of that system, Spaceship 2 by Virgin Galactic. That's a bigger airplane, can carry up to 6 passengers, and already made a couple of flights with passengers on board. So reusable rockets make history. In recent years, after the disruptive advent of SpaceX reusable rockets in 2015, things have started to change. In 2018, the total global space market was 72 billion. Over the past 3 years, governments have spent a total of 216 billion on space activities. Statistics also testify that civil space budgets are exceeding the defense spending. In 2020, the global space budget amounted to 82.5 billion, of which 50.2 billion, 61% of total spending for civilian, and 32.4 billion for the military. Even more interesting, human spaceflight is the world's largest funded space program. Governments around the world with $30.2 billion, surpassing the 11.7 billion invested in Earth observation and meteorology, which have been the most popular application since 2012. Space science and exploration ranks third with a total value of 9 billion. So these are two first stages of a Falcon Heavy that are re-entering at the ground on their own rockets. And this is a Starship, the first fully reusable launch vehicle that will be 2 stages to orbit, both reusable. So the cost of orbital transportation is finally coming down. Who should we thank? At least Peter Diamandis, Gregg, Maryniak, Elon Musk, Jeff Bezos, and Richard Branson, and many other brave entrepreneurs, of course. But let me say, these are the leaders of the new space sector. And of course, the tireless work of the space advocate community over the past 40 years, of which Space Renaissance is one of the organization. The cost of orbital transport is finally downsizing from $54,500 per kilogram, the cost of the space shuttle, to $1,500 per kilogram of Falcon 9 by SpaceX. Civilian space development should grow accordingly. Access to space managed by private companies at decreasing costs. Starship, the first fully reusable orbital system, will further reduce the cost of orbital transportation, making industrialization and settlement in geolunar space finally feasible and sustainable. Starship Super Heavy will cost less than $1 million per launch. In perspective, $20 per kilogram for the transport of lunar payloads. Transporting people into space, such as tourists, workers, businessmen, will cost no more than current air flight. The significance of this perspective is not understood at all, assuming they are considering it by economists. So the new space next milestones will be in 2023, 100% reusable orbital vehicles that will further downsize the orbital transport cost under $1,000 per kilogram. 2025, recovery and reuse of orbital debris could start, kicking off industrialization of the geolunar space. 2030, we can hope in fuel production in space from lunar and asteroid resources that will downsize even more the orbital transport cost, under $100 per kilogram. And 2030, maybe we will see a humanist expansion strategy, development of life and health protection technologies in space, protection from cosmic radiation, simulated gravity, green environment in the habitats, ergonomics, and comfort. So that will mean the possibility of living and working beyond the limits of Earth's atmosphere indefinitely. Residence, to be short. The space economy turnover in 2022 was 464 billion. And these are the percentages composing that pie. Commercial space, 362, defense, 31 billion, government civilian programs, 31 billions, and so on. So space market is composed by manufacturing, launch, ground segment, operation, services, and all of these segments are growing. Oh, sorry. Now let's see a little bit in detail the characteristics and differences of new space versus traditional aerospace. Clearly, the young entrepreneurs are very, very focused on this sector, and they are thinking what they can do in this market, what can be their innovative contribute, and all this kind of concerns and aims to participate and to develop their companies, their startups. The same with the students. Many students have to choose their university path, and they have to understand which kind of discipline to choose, and where they can think to be more interested, more productive, more efficient, and so on. So this was the traditional aerospace, so-called old space. Stakeholders were exploration, science, and telecommunications. And they gave their requirement to space agencies. Space agencies made call for tenders, giving mission requirements to two main big companies, were big and medium companies that were main contractors, and each main contractor participated to the call for tenders, asking for offers to subcontractors for the different parts: electronics, software, optical, mechanical, etc. So they made the system integration and giving the integrated satellite or the mission to the space agency. So this was the market, the traditional market. The paradigm was high costs, long development times, public money, trained astronauts, prevailing robotics, full government control over space, monopoly of a few large company producers of expendable rockets. It was a market driven by public institutions. A new space paradigm is quite different. The list of stakeholders increased very much. We can say the whole humanity is a stakeholder of the program. philosophy, vision, civilization expansion, settlement, industrialization, human space flight, improving Earth's environment by shifting industrial development in space, further exploration, and so on. So the requirements of this big area of stakeholders are given to private investors that are conceiving innovative solutions and being active in several market segments like space tourism, low-cost reusable orbital vehicles, asteroid mining, interorbital transport and services, space agriculture, space debris reuse. Some of these segments are already active, some other will be next year or in a few years. So these companies make space products and services to private customers, no more only to space agencies. Okay, also space agencies continue to be a market, so there will be main contractors still, and but a big market, big new market is developing that is made by private customers that are interested to go into space. Big companies, for instance, in the tourism segment, there are big touristic chains, hotel chains that are interested to move to space, and so on, and so many other. And the advertisement publicity is another market. So many companies are interested to make advertisement in space. So all of these private customers give requirements to the private investors and to the new space companies. And this is a full new paradigm that is characterized by quick, better, and cheaper access to space, pragmatism, business-minded, independence from governance, private capital, civilian space development market is driven by business and vision. So this is an analytic view of the differences. Old space was funded by public money, new space by private finances. Classic supply chain driven by requirements of the agencies, the old space, and the new space companies' mission strategy based on known ideas and innovation goals. Science, telecommunication, and exploration were the only requirements provider, but in the new space we have space settlement and industrialization. So astronautics by military trained explorers, and in the new space we have passengers, tourists, and civilian pioneers in space. So there are a lot of differences. Of course, my presentation will then be available for download. Therefore, I don't want to go in details and on each of these records. So a key factor is carrying civilian passengers means a radical change of mission requirements. For instance, low acceleration, low cost, safer return in the atmosphere, protection from cosmic radiation, simulated gravity, and more. Still other differences. Okay. Many differences between the old space and the new space. This is a chart showing the decreasing of the cost of the access to space thanks to the reusable rockets and the SpaceX action. By the way, it's also interesting to see the differences between space exploration and expansion into space. There are many differences, and if we analyze all of these differences, we understand that explorers should be the best friends of expansionists, because if civilian space development will start in the next years, before 2030, the global crisis will be reversed, and there will be a fantastic economical growth of the global economy. Therefore, there will be money to continue the space exploration, not only space settlement and industrialization, but also space exploration. If the civilian space development will not start, then the crisis will worsen, and probably in 10 years or so there will be no more money, or the public, the political perception will be that there will be no more money for space exploration. Therefore, space explorers, the people that are interested to this sector and consider it, keep on considering it a priority, should understand that they should better help the start of civilian space development, because it will be benefit also for their own sector. So exploration can exist without expansion. Expansion requires more advanced exploration. Exploration is a military concept. Expansion is a civilian concept. Exploration does not require industrialization or infrastructure construction. Expansion requires industrialization and infrastructure construction. Exploration can be done by robots. Expansion requires a consistent expansion of human settlement from Earth into near space and progressively beyond. The exploration is done by public money. The expansion is based on investors and private companies, and so on, and so on. So what is the current scenario of the new space economy? There are many opportunities. So for that young entrepreneur that was thinking what I can do, and for the students, they have to choose their educational path. There are many opportunities. The space environment, first of all, defense against micrometeorites, orbital debris, radiation, thermal stress. An old approach was building space stations by bringing everything from Earth. A new approach is assembling stations in space using in situ resources from the moon and from asteroid materials. The big data and testing is another sector quite interesting and growing. Ground-based simulated space bases, underwater settlements. This is another field of great interest. Exploration bases, to build exploration bases on the moon and the Lagrange points and so on. Infrastructure, communication, vehicles, logistics, research infrastructure. They are speaking from many years. They are talking about an astronomical observatory on the dark side of the moon, where there is no light pollution, no very less electromagnetic noise, and so on. Biotech laboratories, agriculture, greenhouses, hydroponic crops, etc. Raw material production and processing facilities, metal structures, tanks, pipelines, cars, orbital debris and scrap, decommissioning, capture, reuse, privatization of the ISS, mining on the moon, mining on asteroids. These are just the main opportunities, but there are really very much. So building in space, new materials and processes, the friction welding in vacuum, welding in vacuum and zero gravity, layered additive manufacturing, that is 3D printing, construction using lunar regolith, reusable launchers, orbital debris, the cost of the orbiting versus value of reuse. The orbiting is just a cost, but reusing it could be a very, very big business and profit. NASA Lunar Orbital Platform, formerly known as Deep Space Gateway, the Lunar Village, proposed by ESA and by the Moon Village Association, of course, orbital dumps, storage of material for future reuse, transport and towing, aeronautics, civil astronautics evolution, from aeronautics to civilian astronautics. Suborbital flight, spaceports, space robots, human work with humanoid robots, hybrid engines, hypersonic flight, transport, point-to-point at suborbital altitude, progressive miniaturization, and 3D printing solar cells. Okay, the main new space sectors, we already said about that. Yes. Now let's see who is doing what. Space transport vehicles for passengers and goods. This is the market of the launchers in 2022. As we can see, SpaceX is largely dominating the market with 61 launches. China is second with 53. Then Russia with Soyuz 19, and then Rockets Lab, United Launch Alliance, XPRIZE, Astra, Arianespace, the Indian Space Agency, and so on. Main manufacturers are, of course, SpaceX with Dragon on Falcon 9 and Starship, Northrop Grumman, main producer of space passenger vehicles, of course. Northrop Grumman with Sinus on Antares 2030. Sierra Nevada, Dream Chaser, that is going to fly in few months. Blue Origin with a Beaconic space vehicle on New Glenn, under development, and the Crew Capsule on New Shepard, that already made several flights carrying tourists on board. Boeing with Starliner, CST-100 on Atlas V, and Virgin Galactic spaceship company with Spaceship 2, suborbital, fully reusable for passengers. This is, I think, the most comfortable and ergonomic vehicle. Is similar to a to a normal airplane. Okay, SpaceX, his mission is to take civilians into space and to Mars specifically. Was founded in 2022. This, of course, is Elon Musk, the founder and owner. SpaceX completed 197 Falcon 9 launches. Okay, this was 2 months ago. Probably now they have made more, of which 155 landings and 130 reflights. So 5 Falcon Heavy launches, 5 launches, 37 Dragon capsule launches, and NASA chose a SpaceX Starship for sending humans to the moon. Starship is built to be completely reusable and is the more powerful launch vehicle in the world, capable of carrying more than 100 tons metrics of passengers and cargo. And okay, we hope too that the first test flight will be in April. So now, these are the products: SpaceX Falcon 9, 2-stage launcher, reusable first stage, Falcon Heavy, the same with a bigger dimension and bigger capacity for payload, 63 and 0.8 tons at LEO, and so on. The cost per launch is 97 million. Reusable rocket and 150 for spendable rocket. Dragon cargo, reusable, first flight to the ISS in 2020. It already made 6 missions. Dragon Crew for passenger orbital capsule, and okay. This is Falcon Heavy. Okay, I don't go on the details. Crew Dragon, maximum 7 passengers. The Starship. Oh, sorry. The Starlink network is another important reality in the world. is already covering major countries, let me say, excluding the Russia and China and in Africa. Blue Origin, this will be the New Glenn, a big launcher, very big launcher. This thing should fly within this year, the fourth quarter of 2023. It will have a capacity of 70,000 kilograms to 70 tons to low orbit. Okay, so this is the. It will be a reusable launcher, the first stage at least, and the second stage too. Sierra Nevada Dream Chaser. And it will have two configurations: a robot vehicle for cargo transportation and manned space plane. 5 tons pressurized space and 500 kilogram unpressurized. 3 to 7 people crew, destination low Earth orbit, and the function is to supply and transport to orbital stations. It is scheduled to fly first time in this summer, 2023. Boeing is a great dealer and is maybe in the middle of a transition from a traditional aerospace to new space. So it is the main dealer of the Artemis NASA lunar program. It was very much involved in the space station. It is developing a commercial spacecraft, CST-100 Starliner for tourism and production in low Earth orbit, space launch system, and Gateway, the cislunar station. And Boeing is partnering with Lockheed Martin in the United Launch Alliance. United Launch Alliance is made by Boeing and Lockheed Martin. The main operating products are Atlas V, Centaur, Delta IV, and interim cryogenic second stage. And the product in development is the Vulcan Centaur rocket. It will be an heavy vehicle for launching capsules or manned spacecraft. And it will use a BE4 Blue Origin engine that is reusable. So it is maybe the first step of the ULA toward the reusable rockets. These are the performances of the Vulcan Centaur. As you see, a very big rocket. Business model of ULA is quite interesting. Their CEO, Tori Bruno, already presented at least a couple of times from 2016 their plan for geolunar space industrialization, quite interesting, based on regular services among low Earth orbit and lunar and the cislunar space, and yeah, they are designing proper vehicles and cargo systems to allow this model to work. Northrop Grumman, heavily involved in the James Webb Space Telescope, the Antares launch vehicle, the Cygnus shuttle for supply and scientific payloads to the ISS, and the mission extension vehicle, and in the Artemis project, they will provide the solid propellant thrusters for SLS, mission abortion engines, attitude control motors, and they are working on a commercial orbital station, drawing conceptual and different products for defense. Airbus is working in several projects and segments in space manufacturing and assembly in orbit, orbital debris techniques, removal, avoidance, participation in remove debris, space plan, service module for the capsule, Orion, Columbus module on the ISS, communication satellites, Earth observation, science navigation. The Ariane group has two launchers, mainly the Ariane 6, and the new one is still an expendable rocket. It's very much bigger than the previous one, Ariane 5. So the main differences are that Ariane 5 was able to bring 16 tons in LEO, and Ariane 6 20 tons in LEO. Okay. The Russian Soyuz is a transport vehicle for astronauts to orbital station. This system is working for since 60 years from the very initial in the very initial steps of space exploration, and they had an advantage that this vehicle is produced in an industrial model. So they made I don't know how many pieces per year. However, they had kind of production chain that allowed to keep the basic of the design, but to continuously renew and refresh the parts of the entire system. Not so the space shuttles that were made in 5 unique pieces, and when they were old, we know what happened. So these are the Russian expendable launchers, from the smaller to the bigger. The bigger is the Energia. Chinese launchers, Long March, 5, 6, 7, and 9 expendable heavy launcher, and new refillable pitcher, and so on. And let's come to space tourism. This is another sector that will have is having a growth, and will have a very big growth as soon as they will start really to make regular commercial flights. But even now, space tourism is working by allowing people to visit the rocket launch bases in the world, and to have flights on big airplanes that make a parabolic flight, and allow people to experiment a few seconds of absence of gravity at the higher point of the parabolic flight. And okay, so these are the global market value in 2023 is almost 1 billion. The forecast for 2030 will be 8.8, almost 9 billion. The growth rate will be 40% from 2023 to 2030. And areas, the most interested areas are whole world in practice: North America, Europe, Asia Pacific, Latin America, Middle East, and Africa. And the companies that are working in this segment are Airbus Group, Axiom Space, Blue Origin, Boeing, Orion, Span, Space Adventure, SpaceX, Virgin Galactic, Zero to Infinity, and Zero G. So this is the growth of this market from 2020 and the forecast to 2030. Areas with greatest growth. Of course, the United States is the most, the largest market, but also Australia and the East, the Malaysia and all the regions in this part are very much interested. Potential clients, okay. The main companies are Virgin Galactic, Blue Origin, SpaceX, Axiom Space, Space Adventures, and Zero to Infinity. So this is the suborbital flight of SpaceShipOne, reaching about 100 kilometers and coming down at the end, reaching the ignition altitude by the carrier, and then SpaceShipOne will fly along and come back. A few words should be spent about the Dear Moon project, lunar tourism and project, artistic, conceived and funded by Japanese billionaire Yusaku Maezawa. It will use the Starship spacecraft. It will make a circumlunar journey of 6 days with 9 civilian passengers and 2 crew. Production of artistic works during the trip, peace promotion in the world. These are the aims of Yusaku Maezawa for this flight, this project. Blue Origin, suborbital tourism. The vehicle is the New Shepard, reusable vertical takeoff and landing, pressurized pod for 6 passengers without pilot. Maximum altitude reached so far 107 kilometers. 11 minutes is the duration of the flight. And it initiated the flight the 20 July 2021. Orbital debris recovery and reuse is a very, very important sector that is driven by 2 main big motivations and rationales. The first one is to clean Earth orbit from the mess that we have made there in 60 years of launches of satellites. And the second one is to get profit from these materials that are in orbit and are a value, not only a danger, but also a big value. So this is the estimation made about orbital debris in 2021. Dimension from 1 millimeter to 1 centimeter, 170 millions of objects. Bigger than 10 centimeters, 34,000 objects. And 1 centimeter to 10 centimeter, almost 1 million objects. So really a very, very big problem and value. So this is a potential market. Current value approximately 1 billion, the value of the market. 2029 forecast 1.5 billion. Expected annual growth rate 7%. Growth factors: increased demand caused by increasing number of satellite launches and of space exploration. Growing partnership between nations, key to situational alert in space. Obstacles: lack of legal regulation for the space debris. The strategies: the monitoring by NASA is tracking 27,000 objects was in 2021. They use laser tracking and telescopes. Mitigation, limit or prevent the creation of new debris, design satellites that can withstand impacts, use of orbital regimes with less debris, extend the operational lifetime by orbital maintenance, instruct spacecraft to avoid collision with debris, removing the orbit by means of a special propulsion device at the end of operational life, move to disposal orbits at the end of operational life, and reuse a chapter to be written as soon as possible. The companies that are working on this sector, main companies, are the Orbit, an Italian company that invented the device that allow to deorbit a satellite at the end of its operational life. Airbus in the Netherlands, Astroscale in the Netherlands, Clear Space in Switzerland, Electro-Optic Systems in Australia, Lockheed Martin Corporation and Northrop Grumman Corporation in the US, Orbit's Guardians in the US, Obruta, Canada, Share My Space, France, and Voyager Space Holdings in the US. Research Center are the Surrey Research Center in the UK, Center for Orbital and Reentry Debris Studies, Center for Orbital Debris Education and Research, University of Maryland, and University of Padua in Italy. So this is a project by Surrey Space Center, UK, to remove debris, space debris capture experiments with an harpoon, a net, a tow sail for atmosphere, co-funded by European Commission, Airbus, and others. Launched in April 2018, end of mission was December 2022. The director was Professor Guglielmo Lietti. And yeah, the result of the experiment are good, and they can be seen in the on the site of the Surrey Space Center. European Space Agency is thinking about a transition to a circular economy in space by 2050. Services like refueling space, assemble and manufacturing space, orbital depots, space logistics, propellant tankers, warehouse, permanent hosted LEO GEO platform, next generation platform, circular economy, ensuring long-term orbital sustainability through in-orbit servicing. In order to prepare for a circular economy in space, system studies and analysis required to understand the evolutionary need on space infrastructure. Okay, concept. Upper stages are a great source of raw materials. Ariane 5 SK weighs 3.7 tons with 2.2 tons of aluminum. There are a big quantity of these big objects in orbit, and they can be used getting aluminum. Danger objects must be removed. Upper stages are most relevant with roughly 1 explosion per year. Light curve measurements identified upper stages with low rotation periods of more than 30 seconds. A natural deceleration was observed for all. The upper stages are located in geo transfer orbit. Roughly 75% of the moon transfer energy is already paid. Lunar aluminum casting in regolith has advantages like no oxidation losses of the production of large or fragile objects. The lunar recycling infrastructure can be launched and transported with European launcher and vendors. The required technology is currently developed or can be derived from other missions. Lunar use cases, walls, power lines, heat storage systems, and so on. So a great perspective by reusing big wreckages. Space debris and scrap are a huge value. Keywords: recycle, refurbish, reprocess, redeploy, and reuse. There are many tons of precious materials in orbit. Metals such as aluminum and titanium alloys, composite materials, etc. could be used to produce and assemble new generation orbital and lunar infrastructure directly in orbit. Recycling could be used temporarily before the availability of the in-situ resource utilization from lunar and asteroid raw materials. By in-orbit material reprocessing, it will be possible to produce fuel for passengers and cargo transport vehicles. Orbiting materials have one key advantage. They already possess high energy gravity, which was transferred to them during launch. Such materials don't need to be transferred from Earth's surface to orbit. That is the biggest part of the price per kilogram. In Germany, orbit recycling is a project over 8,000 tons of space debris and dangerous or space activities. Satellite operators pay more than 14 million euros a year for maneuvers, evasive payment, and 1 billion in insurance premiums. The orbit recycle program want to do space debris will be carried from orbit to the moon and recycled there. Tons of aluminum can be recovered from the upper stage of Ariane 5. By such material, it will be possible to build large parts of a lunar station, for example, walls, power lines, and heat storage system. Being the materials collected in orbit, transporting them to the moon will just require small propulsion units which can be launched at moderate cost. Over 50 billion euros can be saved in transport costs. Several agencies are working on this problem. ESA, with the goal to add a zero debris net to the Earth's orbital environment in 2030. So neutrality, first step, apply by 2030 the requirements of debris mitigation to orbit. Second step, promoting the circular economy in space, long-term orbital sustainability, term through on-orbit maintenance. US Space Force is also working on this. NASA is working with the proper office, Orbital Debris Program Office, use a collaboration to create a market of space recycling among the Space Force. The NOAA office is the the Oceans Agency, and ACO Recycling in Turkey. I don't know how much time I have spent. Let me check just a moment. Oh,
yeah, you should come to an end.
We are over 10 o'clock, just a moment. Yes, this is a very big presentation, but okay, I will now go a little bit faster. You know that these contents are in the presentation. The PDF will be online, and I will share the link. Therefore, I think that this is a very rich of data, so it can be useful to be downloaded during next time. Okay, the space mining market is interesting. More the Eastern countries. Companies and projects, there are several companies thinking about that. Trans-Astronautica, Asteroid Mining Corporation, Astroforge, NASA, Project Rama. Mining on the moon, can get oxygen from lunar regolith, water, ice and poles, hydrogen, metals, rare earths, helium-3, coal and nitrogen, regolith for construction. And the companies working on this sector are iSpace, Japan, Luxembourg, USA, Moon Express, USA, Lunar Outpost of Golden, USA, Colorado, Mustang Space System, USA, California. Then we have the Habitat, Orbital, Lunaries, and Cislunaries. International Space Station and the Tiangong Space Station are the two existing stations in space today. I apologize for the poor translation because these slides were translated automatically from an Italian language, and I had no time to go into detail to correct the horrible translation. However, this is the International Space Station, of course, and this is the Tiangong Space Station. No, sorry. The Axiom Space is will be the first orbital commercial space station. Partners are Axiom Space, Thales Alenia Space, Italy, and NASA. The launch is scheduled for 2025 in Leo. We house people, research, and production for development of numerous industries using techniques available only in microgravity. Orbital Reef is another project made by Sierra Space and Blue Origin. Operation will be before 2030 in Leo, and mission and business include access to space for everyone, research, technological development, manufacturing, media and advertising, orbital residence, transport and logistics, space rental, hardware system development, robotic operation and services with crew. A Reef starter incubator, completely scalable according to market requirements. Manufacturing in orbit, lunar, and cislunar. These are the companies that are thinking about that. Blue Shift Outward, Cedars, Sinai, Eco Atoms, Grainer, Bio1, Moonfiber, Northeast, Cisloon, Orbital, Space Foundry, and so on. This is a model for factories, orbital factories by Thales Alenia Space, Italy, an autonomous and reusable spacecraft. Sorry, not only Italy, but also France, Thales Alenia Space. Space factory for various industry, Space Cargo Unlimited. The possible interested markets are biotechnology, pharmaceutical products, development of new materials in space, agricultural experiments. And Axiom also is thinking about manufacturing in space. Application, optical fibers, alloys and superalloys, medical implants, organic 3D printing. And lunar production, of course, is another very, very big market that is going to take off as soon as we will go again on our natural satellite. Honda, thinking about working on space. Circulative renewable energy system. Satellite assembly, transport, and maintenance in space. This is another big market. The Orbit, Italian company, the Orbit is working on that. Airbus is working on that as well. Space food and bioproducts, Argotech, Netros Find, Aleph Farms, Redwire, Made in Space, Blue Horizon, Space V, some of the companies that are working on this. People, the technology, deep space ecology, orbital farm, Red Planet Farms. We are trying to contact all of these companies and inviting them to hold a webinar because we're very curious about their project, their technologies, and so on. So in the next month, I think we will have very interesting presentations by all of these companies. Okay. Martian greenhouse. Oh, sorry. Products from low or zero gravity for pharmaceuticals, beauty and personal care, semiconductors, food and nutraceutics. Products from low or microgravity. Okay, this is more detail of what I just said. And protection of life and health in space. This is also not only interesting market, but a very needed activity from solar radiation, from asteroids and cometoids, and from galactic radiation, from supernovae and so on. Also, in this case, we have several research centers and entities that are universities and other research centers that are thinking about that, protection from radiation. Planetary defense from asteroid, Space Guard UK, HERA, DART, PDCO, China, etc. And hypersonic vehicles. Let me go very, very quickly on that, but it's a very interesting segment as well. Okay, space economy in Italy, I think, we can. Italy has one district for each region, and they are very active and working with the companies and making presentation and so on. Aerospace Europe, Italy, and thank for your attention and for your patience. Okay.
Thank you so much, Adriano, for this very informative lecture. We got more people also from Canada and from Qatar. And we have the first questions from the chat. Werner Grande is asking, do governments in the US, Europe, China have a detailed plan for milestones into space? It will not be done by private companies only.
I think that question was to you.
This question was answered now during the lecture.
Should I reply now?
Oh, no.
Right? Okay.
Yeah.
Okay. So I think we would like very much to see a coherent strategy by the governments and the main space agencies about civilian space development. So tackling the issues that are to be faced in order to allow normal people to travel and work in space. It is protection from radiation, simulated gravity, and the green environment in the habitats and all these kind of things. Because these kind of challenges are the real condition that will allow to start expanding into space. So we would like very much to see the space agencies, because these are problems of research, scientific research, not only of investment by private. So of course the collaboration among private and public sector is very much needed if we want to be serious in expanding civilization into space. Therefore, we are also in September, we will hold a panel at United Nations General Assembly 78, calling for adding an 18th SDG to the 17 Sustainable Development Goals. And the 18th SDG will be space for all. That means civilian space development and life beyond Earth. So, we have to work very much to call, and we have, and I can say, I'm very happy to say that we are reaching. We have there are many allied organizations that are reaching us in this proposal, and the first one that I want to nominate is Frank White, which is a human space program organization that just today brought me his acceptance of our proposal to talk in that UN panel. So yes, Einar, we are trying to do our best to convince politicians of the needs that we have, that humanity have.
Yes. Okay, here are more comments. Samuel is saying actually took years for XPRIZE to raise 10 million starting in 1996. Eventually, they found Ansari, and the event was renamed the Ansari XPRIZE. This for the beginning of your lecture. There are more comments, not so much questions in the chat. And I think the words secure future, which depends on space technology, depends on what most people spend their money and time on, plain and simple. And Samuel is saying governments change their space vision every few years, depending upon politics and budgets. It's true, but I think, I personally think that space has got a real boost with Elon Musk and his SpaceX, and the competition now between the billionaires. And there's a little interest by all space to reduce the cost of access to space. Government contractors just want to get paid. And he also says the biggest barrier to space settlement is infrastructure, fueling depot, factories, hotels, laboratories, solar power stations, and emergency support services. And he also says, and space debris mitigation, someone has to build a garbage truck. This is true. It's a big problem. And I think space is a new frontier and can easily change the economic balance. Therefore, we are most served by removing the monetary system. If we do that, the cost problems are removed for good. We can discuss this. I read what is in the chat and then we can talk about this. Ina also says space could become the money system's device downfall, something that might frighten some in power. And based on the existing monetary system, we are best served by getting the new generation to culturally change their perspective of reality and build the future on their innate scientific hunger. So, and Werner is adding, for real space tourism, we need a rotating orbital station with simulated gravity. ISS will be decommissioned in 2030, but the rotating system, from my opinion, has a problem that that's only the free power and not a real a real gravity system.
And it depends from the dimension.
Okay. And okay, Werner says he has designed a prototype rotating station. Presentation is in Baku at IAF Congress in October. Samuel is adding a circular economy, nice, and a great presentation. And here's from Norberto Urbina, congratulations on your presentation.
Very much.
Very interesting and a lot of information. Greetings from Mexico. Hola, saludos a Mexico. He appreciates the invitation to watch the broadcast, and you can join us every first and third Monday. Ana is also thanking for the great and detailed lecture, and Denise Alfonso Rivero says, the possibility to have water-based propulsion is another aspect that can be a game changer. And the word is not enough, is a concept for a new generation of spacecraft that takes advantage of in situ resource utilization to explore space.
Any question? Mm-hmm.
And from Priscilla as a question, have we seen any numbers on how much total input to world economy the space sector will add?
Well, yeah, let me let me touch 2 points that you mentioned in reading all of these things. The first one is the point of the simulated gravity, because I think it's very important. And unfortunately, we have 2 projects of commercial space stations, but none of them are thinking to be rotating. So they will still work in microgravity and not in simulated gravity. And definitely it would be time to start experimenting, at least experimenting that, because we don't know anything about that. We have to try because it's not possible on Earth to simulate zero gravity or other things. So we have to go there and start to experimenting. And the problem of the perception, it depends from the dimension, and the bigger the dimension, the lower can be the velocity of rotation. So if the velocity of rotation will be slower, also the Coriolis effect will be lower. So we can enjoy a 1G in the proper way. We hope so. We don't know because we have to experiment. So this is the first thing. The second question, very important to me, is how the new space economy is impacting the global economy. It is impacting very much. In my opinion, the space economy is now the leading factor of the global economy, because there are, in the situation that we have in the world, there is no other economic sector that is growing at the same pace. So the forecast, 2 years ago, the forecast of the economists was 1 trillion, the space economy 1 trillion in 2040. Nowadays, they think that 1 trillion will be already reached in 2030, and we think even more. If the civilian space development will really start, we will have maybe more, maybe 1.5 trillion in 2030. That means that the space economy is really leading the global world economy. And this thing should finally move the stubborn head of many people that don't believe in this perspective.
Yeah. Here's,
Maybe Bernard will have something to add.
Yes, but Denise has a comment. Wine, also the bird is not enough. The wine mines to extract water from planetary regolith, capturing the water as ice in a cold trap and heating it to create steam for propulsion. This is just an example. There are other people interested in using water as propellant.
Yes, definitely. That is a very interesting concept, and should be considered. Yes.
Yes. And now I give over to Bernard. He has also some questions. I have to apologize because I'm waiting for a call, and it can be that I have to leave earlier. So I give now the word to Bernard, but in case that I have to leave, I would apologize. Okay, Bernard, the floor is yours.
Thank you very much, Sabine. And so, yes, I'm here surrounded with some of my astronauts. They are all analog astronauts. They already spent 1 week on the moon in the base without window in one of our Human Mars Poland campaign. So they are already training for this next phase of living in orbit or beyond on the moon. And actually, so there is Ava Hutchinson. So she's an international relation expert interested in space. She has a question for Adriano.
Hello. Once again, thank you so much for having us. Adriano, is a fantastic presentation. Congratulations. I did have a question. So from your perspective, what is sort of the key takeaway for young professionals that are entering new space economies? What is, important things that we need to strive for, to keep in mind, that anything of that nature?
Oh, yeah, very, very good question, of course.
Wait, before you answer, can you change the view that all speakers are seeing?
Yes, we can certainly try.
No, Bernard, Adriano has to do that. Adriano has to make the view in a different way.
Oh,
Oh, yes. Thank you. Thank you, Sabine. I always forget this thing. Yeah, you're right.
Yes, I wrote you some messages in the chat, but
so first of all, it depends for each person. It depends what is the main aim and the characteristic of their mind, and then what they want to do. If they are interested to science, to technology, to philosophy, to psychology, to medicine, also, okay. But I think that the most important points for us, for space analysis, I mean, were defined in the final resolution of our Congress in 2021, where there are about 12 points that touch the main priorities in our analysis. That are the points that should be approached and tackled in order to help the civilian space development. For science and technology, the protection from cosmic radiation is maybe the first thing to think about. So if I were a 20 years student, young student, and interested to science, then I will try to work in that activity, discipline. And
for a young lawyer like Eva?
Yeah, a young lawyer should take care of enhancing the space law in order to allow space debris capture and reuse, because nowadays it is not so. And if you go in orbit and you catch a big wreckage and a dismissed satellite, the owners of that thing can bring you to a court because that thing is not yours. In international laws on Earth, it is different, because if you find a wreckage in the sea that can be dangerous for navigation, then that thing is yours, and you can bring it in a port, and you can sell it as a wreckage, and okay, the recovering of that dangerous thing is rewarded, is recompensated by the ownership of that. So this, I think that this simple rule should be extended in outer space, as the duty to shelter, to recover people in danger in space. That should be another thing that could be. So I think the international seas laws could be a good source of rules to be mined and brought to space. I think that, but I'm not a lawyer, therefore you should maybe join our space law committee that is chaired by a lawyer, Marlene Lozier, that is specialized in space law. And for sure, you would find an environment where this discussion is made with properly arguments, and okay.
Perfect. Thank you so much.
Yeah, actually, Eva has been working on comparing outer space treaty and the international deep sea laws. So she could bring also this new view. Now, okay, you have talked about space for all, and as a measure we want to propose to the United Nations. You have mentioned in the history the eminent role of the US, Soviet, Russia, the strong role now of China. And so what do we have as a role for Europe, trying to keep up, and for emerging space countries?
Yes, I would say as a general concept that the contribute of all countries, so-called advanced countries and emerging countries, is very, very important and needed, because the challenge that we are facing to start expanding humanity in space is the biggest never ever faced by humanity. Yeah, okay. All is commiserated to the time and to the available technologies and so on. So maybe it's not true that is the biggest one. For sure, the people who built the pyramids had a similar problem to be one, and so it's not honest by me to say that this is the biggest. But of course, for us, it's big enough, and therefore the contribute of all people in the world is quite important. What can do Europe? So Europe, Europe already made a lot for space, because think about Earth observation, about telecommunication, about science, payloads, about the probes for Mars and for Cassini for external planets and so on. So it is a big contribute that Europe already gave to space. But what we could say is that maybe Europe is a little bit in delay with regards to human space flight, because Europe is not part of the so-called astronautic club that is still only 3 countries: USA, Russia, and China. So maybe Europe should think more about bringing humans in space. And for sure, the proposal made by Jan Werner some years ago, that was the initiator of the concept of the Moon Village. It was a tentative to shock a little bit and to push to move ahead, to go to the moon, go forward to the moon and not go back, as Jan Werner said. So for sure, ESA has a lot of things to do, and we should, if the young students that I see here aim to go working for ESA, they should go there to disturb, not to be, followers, but to go there and to bring ideas and bring innovation and bring movement. Okay, so this is
indeed to move forward. So space for all, moving forward and getting the skills from different disciplines, but also some new skills with some of the challenges of new space economy, not only for money, but also for sharing some of the benefit with humanity in a fair way. So that's one of the principles of Space Renaissance, to be inclusive, but also to try to have an impact on humanity, on Earth and beyond. So really on behalf of our group here that is also working on some of the science, the technology, the legal aspect, the human aspect of training astronauts, we really want to thank you, Adriano, for a very comprehensive lecture. We will look back at it to study some of the very complete slides. And I want then to give back the floor to our moderator, Sabine, to close this very beautiful webinar. Thank you.
Yes. Thank you so much, Adriano, for your wonderful presentation. It was very, very compact, very informative, and very good. And thank you, Bernard, and your students for joining us. It's really nice. And thank you to our audience for joining us, for all these comments, for the questions. Also, there was a lively discussion in the chat. And Bernard has one remark.
Yes,
see.
Of course, I always forget. So I want also to mention an activity that is prepared by one of our Space Renaissance International partner. As you know, we have signed an agreement with Eurospace Hub. So it's a consortium of universities. And you have seen some of their work at the International Astronomical Federation committee meetings in Paris, where we just could meet Adriano and a number of partners. And Eurospace Sub is organizing a special forum, Eurospace Sub Space Forum, and that will take place in Ibiza, but we will talk about innovation, about astronautics, about business. So please look at our website and register. We are looking for even some additional panelists to join us. So look at it and you can register online.
Yeah, thank you for this information. And I also would like to inform you that our next webinar will take place on the 17th of April. Celia Avila-Rauch will talk about introduction to space psychology. And this is a very interesting topic, I think. So please join us the next time in 2 weeks at 9 o'clock. And thank you for coming. Thank you for joining us. And I wish you a nice evening. Thank you, Adriano, again. And goodbye, everyone.
Goodbye.
Thank you so much.
Thank you.
Ad Astra.